In class today, you're going to work on a puzzle with a partner. For this puzzle, you have various puzzle pieces. They're all equilateral triangles. You're going to know which puzzle pieces are edge pieces because they don't have an expression on that side. So, for example, this puzzle piece is an edge piece, and this is the edge. These two pieces are not edge pieces because they have expressions on the side. This piece, on the other hand, is definitely not an edge piece anywhere around because there are expressions on all three sides. When you read these, you might wonder whether you're reading them right side up or upside down, depending on the numbers that are there. So, for example, some students weren't sure how to read whether one was a 6 or a 9. I'm trying to find one that would work. So on this case, they weren't sure if that was a 6 or a 9. And it's 9 minus 3x because this is the flat surface right here, and you're going to read what's above that. So this is 9 minus 3x. This is 7 times the quantity x plus 4. This is 12 minus 3x. Read it like that. So back to this piece. We know that's an edge piece. And when we put all of these pieces together, and there are quite a few, when we put all of these pieces together, it's going to form a hexagon. And in a few minutes, I'm going to show you what that hexagon should look like. But for right now, I need to show you how the pieces go together. So this piece says 3 times the quantity 4 minus x. When you and your partner are working on this, you should have a whiteboard in front of you to be working out these distributive property problems. So this is 3 times the quantity 4 minus x. So I'm going to do 3 times 4 is 12. And I'm going to do 3 times negative x is negative 3x. Remember, when we're multiplying a number times a variable, the number part always comes first in that term. So we wouldn't say minus x3. We would also always say minus 3x because that number part goes first. You might see the answer written in this order, or you might see it in the other order that we talked about with the foldable, which is putting the term that has the variable in it first. So remember, the negative goes with the 3x. So negative 3x would come first. And then this is positive 12, so I would write positive 12. The expressions are written in a variety of ways, so I can't guarantee whether it's going to say 12 minus 3x or negative 3x plus 12. You need to be aware that it could be written in either format. So this is the piece that matches this one along this side. So we're not going to put it like this because 9 minus 3x does not equate to 3 times the quantity 4 minus x. 3 times the quantity 4 minus x equals 12 minus 3x, so these two pieces match up. You're going to continue working around like that, working on the whiteboard as you work, watching out for a couple of common mistakes. So one common mistake with the distributive property is that when you have something like 5 times the quantity x plus 3, students usually remember to multiply what's outside the parentheses by the first term in the parentheses, so 5x, but they often forget to multiply by the second term, and they just write exactly what the second term is. 5x plus 3 is incorrect because we haven't multiplied 5 by the second term in that expression. So that's wrong. So let's go back. We know the first term is 5 times x, or 5x. The second term of our new expression is going to be 5 times positive 3, which is positive 15. So if that were on one side of our triangle, we would look for another triangle that has 5x plus 15 on its side. Watch out for that common mistake of forgetting to multiply by the second term. Another common mistake is if you had something like 4 times 2x plus 1, you'd have 4 times 2x, which is 8x, and you would have 4 times positive 1, which is 4, positive 4. But if you are not careful and you're not paying attention to the fact that that is a plus sign and you're just quickly looking through all these pieces to find what you're looking for, then you might not notice that you've picked up a piece, for example, that has 8x minus 4 instead of 8x plus 4. Those two expressions are different, and so you would have to be looking for the one that's exactly what you want. There's a little extra challenge on this problem, and that is there are a couple of spots where there are two possible matching pieces to go with one of the expressions. You're going to have to use context clues, in this case the pieces that go around that spot, to know which one is the correct piece to use in that location. Back to how this all goes together. So we have an edge piece, and I'm just going to start putting pieces together that actually don't match. I just want you to see how they match up to make a hexagon. So we start with 2 hexagons along each side. So 2 hexagons that don't have an expression on that side go together. And then this one would be an inside piece. So if this matched that and this matched that, those would go together. And you're going to keep working like this, but when you turn the corner to the next side of the hexagon, it's going to look like this. So we have 2 pieces going along this way. We're going to have 2 pieces going along this side of the hexagon, and then we're going to turn the corner and go in this direction with another edge piece and another edge piece, and so on. So you can start to see the side of that hexagon taking shape. It's going to be overall this shape, not going to be just 6 pieces put together. It's going to be all of these pieces put together. And when you're finished, you need to have it checked. So make sure you don't blow it over with a sneeze or step on top of it or something like that until it can be checked. Also, one more thing to keep in mind is that when you have matches, all of the matches have one side where the expression is written using the distributive property with parentheses, and the other side is just written simplified with no parentheses. You'll never have parentheses matching up with other parentheses, or no parentheses matched up with no parentheses. That should help a lot.